welcome back to Dragonfly Engineering. So this week we've got a quick modification to a prototyping mold that we're going to do, and it's another polycarbonate part similar to last week. I'll show you a picture up close here in a second. But what we need to do is cut out a clearance in the radial rib here on the part on the bottom to allow for a pipe to fit through. So this is just part of the prototyping process. I build these molds quick and with the intention of modifying them to prove out a bigger assembly or a product or whatever. So fortunately this mold is a quick aluminum mold, so we can make the change pretty easily. And what we're going to do is we're going to drill and machine a precision tight fit hole for a dowel pin, this 1/2 inch dowel pin, to basically fit all the way down through and into the cavity of the mold itself. And then the profile, the half shape of this dowel pin is basically the clearance we need for this rib to be cleared out for clearance for a pipe in the greater assembly of this polycarbonate part. So I will, let's zoom in on the mold here and we can talk more about what we're gonna do. Okay, so this is the part that this mold makes, this polycarbonate part. And you can see that there's a rib structure around the outside, this spoke pattern, and then there's a radial rib that goes all the way around, or like an edge skirt. And we need to cut out or make clearance in this area right here. You can see that I use the manual mill over to the left to machine out this kind of triangular bay for clearance for an object to fit in there. But you know, we don't want to do that continually in machining these parts. We'd rather just modify the mold, and then this part fits in the mold like this, and then it ejects out, and there's a bunch of 16 or 1/16 ejector pins around this structure here to knock this part out. So fortunately we don't have any problem with ejector pin interference, and we are going to basically sink this steel pin right down through the top of the mold to create the negative feature that would create our clearance in our wall right here. I was thinking about using the threaded tip of this pin. This 1/2 inch dowel pin has a 1/4 inch or a 1/4 20 thread in the end of it. So I brought up the CAM program in the computer that originally was used to machine the mold cavity for our project here. And you can see that I've shown the top surface of the mold. That's that surface that you see kind of levitating above everything. And then down in the middle is the actual machine part. Here is where I drew the circle at the top to depict where the end mill is going to cut our pocket for that dowel pin to fit into. We're also going to pilot drill down the middle with a number 7 drill, because we're going to tap the bottom of this hole with a tap as well, so we can screw our pin in. So here I'm just checking how the drill bit fits, and it's coincident with the bottom of the cavity there, you can see in the wireframe image, because I wanted to make sure that the drill bit wasn't going to break through. So here is the tool path for the 3/8 end mill, and you can see the animation. So all those blue lines are circles, and the lighter blue lines are like the helical paths, which may be purple in this image. Anyway, I'm just showing how the tool is going to behave as we machine our 2.5 axis pocket down into just past the wall of the rib in the part, such that the dowel pin actually terminates into a hole inside. And here you can see how the end mill is going to kind of poke through the inner structure of the cavity. So we're going to tap a 1/4 20 in aluminum, so number 7 drill is the size to use. And depths are not critical, so I'm going to set this tool height. Next tool is going to be the center drill, which is already loaded. I got this thing like a 280 pipe hole. Okay, we'll load this guy and set its height. None of these depths are critical because our new feature in the mold, this shaft, is going to pass through the cavity and into the meat of the mold, so I don't have to be very accurate on setting tool height, so I'm just going to visually set it. I'll make sure I'm at the actual 0 position, so I'm going to tell it X0, Y0, and cycle start in the MDI interface. and it took me to the actual 0 of our mold location, which is the same as in the CAM program. So I think we are ready to go. I will go ahead and hit start. So hit menu, make the rapid slow, and hit cycle start. I can speed it up for a tool change. I'll slow it back down, and I'm ready on the feed hold button. It's always good practice when you're working on a new mill program. And we cut our pilot hole. And now we will drill our pilot hole for machining out our precision hole for the dowel pin with a 3/8 end mill, as well as drill deeper so that we've got a pilot hole to tap the 1/4-20. I think I'm just going to manually tap this one because I don't want to deal with having the tool holder run into the mill, because it's the thread is actually going to occur down here. And I'll get the coolant going. Whoop. Okay, I'll increase the speed and I'll zoom you in. Now hopefully I will not see this drill bit break through the cavity other than where I'm going to machine out for the dowel pin. And we're done. I'm going to slow this down to make sure we enter correctly. Then it gives me a chance to reset coolant and things like that. Okay, it started into the helical spiral, so I'll increase the rapid to 50%. I think I'll slow down the spindle too, because we're getting bird nest. There we go. Okay, now we're cutting our dowel pin hole. I already had the polycarbonate drying, so after we set our hole, our dowel pin into the hole, then we can just take it right over to the molding machine and load this mold up and see if our modification worked. Okay, that's it. So let me get a pin and we'll try out the fit. All right, here's our dowel pin that we're gonna stick into the mold down through there in this hole. And I machined this hole to be tight, and it looks like, or basically with 0 clearance. So a 1-inch pin does not fit into a 1-inch hole. As you can see, you need a little extra room. So I think what I'm gonna do is write a new program for just a finish cut on this end mill to add a stock remaining of -20 microns, or a little less than 1/1000th of an inch all the way around. So that should give us enough clearance. And this can also act as a vent for the mold cavity itself. Even though we have a bunch of ejector pins in the cavity, it never hurts to have additional venting as well. All right, so let's try our pin. So we had clearance at the top, and as I push it in, it gets a little tighter and tighter. It bottoms out about here, and I don't want to go any further because then I won't be able to pull it out. So let me gently pull this pin out. I think I'll rerun the program and see if that cleans up and gives us a little extra clearance for this pin to screw or slide down and screw in a little easier than what it is. So one more time. I can speed it up. All right, I'll back this out. There is some dust on the end mill, so we did something. Well, yeah, it's going in deeper now, and it's passing the threshold, so we're just, I think we're there. And then I think I'm going to grind a little bit off the end of the pin. on the surface grinder to help with the transition, just so we don't have any weird undercuts because this pin has a kind of a domed tip to it, so we'll grind some of that off. Okay, I got you over here on the surface grinder, and I've loaded our pin into this little toolmaker's chuck here. Now what we can do is, this will be a real quick grind, so we're going to bring the stone down close, and we'll turn on the grinder only. Make sure my mag chuck is on. We'll come in from the outspin side of the stone, and I'm basically just going to grind the dome off of the end of this dowel pin. I move around on the stone a little bit. Add a little more, we take off. And this is just so we have a nice sharp transition in the round pocket in the mold that we made, and this pin will fit into that pocket and not have any of that exposed radius on the tip of the pin. All right, so on to the next step. Okay, so we got our hand tap and our tap handle, and we've got our tap follower with a spring-loaded tip. You see how that springs up and down? And then what we're going to do is pull out the old drill bit here, whatever it is. And I use this big drill chuck because it'll hold my tap follower. We'll load in our tap follower. I'll lightly tighten it because it doesn't really need to do anything other than hold the center of the tap. So we'll bring our tap tool in, and then I'll guide down our center spring-loaded tap center here, and basically bring it into that hole. And I like to make sure I'm not bottoming the tap out by having a little bit of vertical play. So now our tap should be centered and perpendicular to the hole we drilled, and now I'm just going to start tapping this. Oh, it fell down in, so not sure what that was about, but let's bring this down again. I probably seated in the tap handle. Now I'm just going to put just enough of a thread to anchor. This tap handle isn't very tight. And once you start your thread, then you don't really need the center because you've kind of started into the position. Let's get that tighter. Okay, there we go. I like to leave the handle a little loose because you reduce the side load, you know, the side torquing on the tap. So, but you just want a socket that fits the square end of the tap, in my opinion, when you're hand tapping. Everyone's got different opinions. So to keep the hex key stuck on the end, or the hex socket of your part stuck onto the end of your hex key, you can double up a rubber glove and create a rubber membrane that springs and holds your part in place, and then break through. I tried with a single layer of rubber glove and that didn't work, so let's see if with 2 layers of rubber glove works. And yes, it does work. So now we can drop this hex key down into our threaded hole. I'll find it by feel, and then we'll screw our threaded stud in like so, and that's tight. So now we got our guy in there, and there is a little remnant of rubber glove stuck inside of the hex socket of that set screw, but that's okay. Now what I'm going to do is make sure I can screw our pin in, but I probably do need to cut a screwdriver slot into the tip of it, but I want to see that I can hold it in there, and it looks like it's well enough aligned where I can go ahead with the die grinder and cut a little screwdriver slot in the top of this pin. Okay, so we are just about there. So let's go ahead and drive our dowel pin in. And I got a screwdriver here that should fit in our slot. And we'll just screw this guy down. Yeah, there we go, we're tightening up. It's definitely traveling on that thread. Okay, well let's go ahead and load this guy onto the molding machine, and we will make a few hundred of these prototypes with the updated clearance hole in the side round outer rib of this part. All right, so we are ready. So this mold, I believe, has threaded holes on the front. So we are going to use some of these through bolts. These are 3/8 bolts. So I put this board in here to ensure I don't drop the mold. And then here's a temperature isolator. I've shown this process a few times on previous episodes, but for those who are just tuning in, we will quickly go through the process of loading a mold into the molding machine. So let me turn on the other camera. There's a machined in guide ring in the front of the mold, and then these are the mounting holes, these threaded holes. And then this port in the middle is the nozzle where the hot plastic squirts into the cavity. So we're going to line this ring up, which is 110 millimeters, with the ring and the platen of the molding machine right there. And our new post that we just added is a good indicator of what is up. So we'll have the cavity up. And we'll stick that in. It's a little heavy, but I'm reaching through and I'm starting the screw. Nope, it didn't start. I think I need to put like one of these toe clamp blocks under the mold to hold it up. All right, so this fiberglass spacer is a little thinner than that other one, so maybe that will help us. Because there isn't much overlap with this mold and the alignment ring in the molding machine. And that's because this mold is actually going to be pretty hot. It's going to be 220 degrees Fahrenheit. And the more metal on metal we get, the more heat I'm wasting trying to get this mold up to temperature. Yeah, that's engaged well. It feels snug. As soon as I start the screw, then I don't have to sit here and kind of hold it. So I'm tightening the bolt down and it's drawing this mold up onto the A side and lining the mold up with that alignment ring. Like so. Okay. Okay, so our mold is attached to the A side of the molding machine, so I can pull this board out. Now what we're going to do is start up the molding machine, and we will load the program for this mold, bring the B side of the machine clamped up to the A side, and then finish attaching everything. A lot of times I'll pull these clamps out, but we'll see if we clear. And we can also use our heat shield on the back side. So we're going to put a second heat shield here, and then a 1/2-13 bolt with a coupler to the ejector system in the back of the molding machine. So I think I'll just time lapse some of this. All right, so we got the mold loaded, and now it's just a matter of waiting for the mold to heat up to about 240 degrees C, and for the plastic to heat up as well. Polycarbonate is pretty high temperature molding plastic. Let's see what our temperature target is. So 490 degrees on the nozzle input to 550 degrees at the nozzle output, and that's Fahrenheit. So let's go ahead and get this injection unit warmed up. And so I will turn on the heaters, and then we will be back once everything's warmed up to mold our first parts. I also have the polycarbonate drying in a plastic dryer in the back, so I'm going to bring some of that in too. All right, so I'll be back once we're up to temperature. So, manual mode, and what we're going to, so this is a depiction of the screw auger in the plastic injection unit. So this thing is what is at 500 and, it's somewhere between 490 and 550 degrees Fahrenheit. And we're going to go to the basically injection unit page of this molding machine, and I'm going to tell it to push the auger forward. And off camera, there's going to be plastic that squirts out of the nozzle. And you can see how the depiction of the screw nozzle pushed forward. So now what I'm going to do is turn the nozzle, or turn the auger nozzle assembly inside of the injection unit. And there we go. Oh, actually I'm going to slide the hopper to feed polycarbonate into the injection unit. And I saw some plastic fall into it. So now we're going to spin the injection unit and then squirt out plastic. And spin again. And squirt out. So right now the program for this part says that we need to load 30 millimeters of travel of the auger to get enough plastic to fill the mold. But what I'm going to do is cheat and tell it to fill more to the full capacity for purging out the plastic. Okay, and I'll just keep doing this. It basically looks clear. It's hard to see through the foggy window here. So let me open up the door. And then that's what it really looks like inside. So that's nice clean polycarbonate, and you see how it's oozing out. So I think we are ready to mold plastic into the mold. All right, so we've got the molding machine heated up to the proper temperature on its hydraulic oil. The shot is loaded and at temperature, and the molds are at temperature, and the mold is in its starting position. So I'm going to hit semi-automatic mode and cycle start, and we'll see what happens. There we go. It clamped up and shot into the mold. It went to 0 on the travel, which isn't great, but it can happen on your first few parts. You know, the first cycles are never quite right. Yeah, we got a partial fill. And what do I have, the ejector system off? Okay, I figured it out. I basically had no travel set for the ejection. So let me hit the ejector pin forward, and there's the part ejected, but it didn't eject completely. So let me increase the travel to 42 millimeters, and we'll eject a little more. We need some more travel, so let's do 50 millimeters just to make sure. So I'm going to hit the ejector forward button again in manual mode, and there the part fell out. So let me open this door so you can see the ejector pins and the B side of the mold a little better. Okay, so here's the B side of the mold, and I got my cell phone as well, so let me hit record on this. And you can see here the features on the B side. So you can see all the 1/16 ejector pins, which are approximately 1.6 millimeters in diameter. And the ejector pins basically are at all the vertices of the junctions of the ribs, the outer round rib and all the spoke ribs. And then there's an array of ejector pins in the middle to eject in the middle. It's better to have ejector pins on the tips of ribs as opposed to flat, wide areas, because the rib helps distribute the force of the ejector pin around your part. So anyway, that is the B side. And then the A side over here, which is basically just another steel insert that is a funnel shape with a center shutoff port. Okay, so I hit the cycle start button again, and we have a cushion of plastic about 5 millimeters, which is good. And now we've got a full shot and the part ejected. And we are running an automatic, so that was pretty easy. To be full disclosure, I've already run this mold in the past. We only really added that one notch addition to the mold, so I'm not surprised that it's running in automatic mode. And currently the cycle time is 23 seconds per part. So here's the next one, and that one ejected as well. So let me go ahead and zoom in. There we go. So I'm going to switch this back to semi-automatic mode so it stops after the cycle, the molding machine stops. And we will take a look at the part. So this is the part as molded. Let's see if we can get an up close. Yep. Yeah, so you can see that. You can see the notch there, which is created from the dowel pin that we added to the mold. It looks pretty good. I don't see any issues with flash or anything like that. Well, I think that pretty much wraps it up for this modification to this mold. So thanks for watching, and I'm going to mold about another 100 or so of these for the customer. I'd also like to give a special thanks to my patrons who help contribute to these videos and make them possible. And I'd also like to thank all my viewers and subscribers to the show. Also, if you'd like to leave any comments below, that would be appreciated. And I'll look forward to seeing you guys next week. Or actually, I think I may do a double feature this week. I'm going to get back on the green robot mounting and all of the painting and setting up of that as well. So stay tuned, and I'll see you guys soon. Thanks for watching. Bye.